We use addresses to find locations in a city, but how do we locate a position on Earth's vast surface? The answer lies in a system of imaginary lines called latitude and longitude. Latitude and longitude provide a unique address, or geographical coordinates, for every point on Earth. These coordinates are crucial for navigation, mapping, and understanding our planet. Latitude lines circle the Earth horizontally, parallel to the equator. The equator, an imaginary line encircling Earth at 0 degrees latitude, divides the Earth into the northern and southern hemispheres. Lines of latitude, measured in degrees north or south of the equator, tell us how far a location is from this central line. Longitude lines run vertically from the North Pole to the South Pole. They are not parallel like latitude lines, but converge at the poles. The prime meridian, passing through Greenwich, England, is designated as 0 degrees longitude. Longitude lines, measured in degrees east or west of the prime meridian, indicate a location's angular distance from this line. Understanding latitude and longitude is essential for pinpointing any location on Earth. Whether it's a bustling city or a remote island, these coordinates provide a universal language for describing our position on the planet.
While latitude and longitude may seem like abstract concepts, their impact on our lives is substantial. These lines form the backbone of maps, charts, and global positioning systems, GPS. Without them, accurate navigation would be incredibly challenging. For centuries, sailors relied on celestial navigation, using the stars and sun to estimate their latitude. Longitude, however, proved a far more difficult problem to solve. Accurate determination of longitude at sea was crucial for safe and efficient voyages. The development of accurate timekeeping devices in the 18th century revolutionized navigation. By comparing local time with the time at a known reference point, such as the prime meridian, sailors could finally calculate their longitude. This breakthrough had a profound impact on exploration, trade, and global connectivity. Today, latitude and longitude are fundamental to modern technologies like GPS. Satellites orbiting Earth transmit signals that allow GPS receivers to determine their precise location using these coordinates. From finding our way in unfamiliar cities to tracking shipments across continents, latitude and longitude are woven into the fabric of our digital lives.
The quest to determine our location on Earth is an ancient pursuit. Early civilizations observed the stars and sun, recognizing patterns that helped them navigate. The Egyptians, for instance, used the stars to align their pyramids with remarkable accuracy. The Greeks made significant contributions to the development of latitude and longitude. The philosopher and geographer Ptolemy, in the 2nd century AD, devised a grid system using latitude and longitude lines. His work laid the foundation for modern cartography. During the Age of Exploration, the need for accurate navigation became even more critical. European explorers ventured across vast oceans, seeking new trade routes and territories. The lack of a reliable method for determining longitude at sea posed significant challenges and dangers. The invention of the marine chronometer by John Harrison in the 18th century was a pivotal moment in navigational history. His accurate timekeeping device enabled sailors to determine their longitude with unprecedented precision, ushering in a new era of exploration and global trade. Section 4. Measuring the Earth's latitude and longitude. Latitude is relatively straightforward to measure. The angle of the North Star above the horizon corresponds to an observer's latitude in the northern hemisphere. In the southern hemisphere, similar observations of specific stars can be used. Longitude, however, presents a greater challenge. As Earth rotates, every point on its surface except the poles moves through 360 degrees of longitude in 24 hours. This means that each hour of time difference corresponds to 15 degrees of longitude. To determine longitude, one needs to know the time difference between their current location and a reference point with a known longitude, like the prime meridian. Before accurate portable clocks were available, this was impossible to do precisely at sea. Today, with atomic clocks and GPS technology, we can easily determine our longitude. However, understanding the relationship between time and longitude remains crucial for appreciating the historical challenges and ingenuity involved in its measurement. Section 5. From sextants to satellites, modern navigation. For centuries, sailors relied on tools like the sextant and celestial navigation to estimate their latitude and longitude. The sextant, invented in the 18th century, allowed mariners to measure the angle between the horizon and celestial objects like the sun or stars. By comparing these measurements with nautical tables and charts, sailors could determine their approximate latitude. Combined with accurate timekeeping using a chronometer, they could also calculate their longitude. These methods, while effective, required skill, experience, and precise observations. The advent of radio navigation in the 20th century provided a new means of determining location. Systems like LORAN, long-range navigation, used radio signals from fixed stations to allow ships and aircraft to calculate their positions. Today, GPS has revolutionized navigation. A network of satellites orbiting Earth transmits signals that enable GPS receivers to determine their latitude, longitude, and altitude with remarkable accuracy. This technology has transformed navigation, mapping, surveying, and countless other fields. Section 6. Latitude, longitude, coordinates for a connected world. Latitude and longitude are more than just abstract lines on a map. They are the invisible threads that connect us in a globalized world. From shipping routes to flight paths, these coordinates underpin our interconnected society. Understanding latitude and longitude allows us to appreciate the Earth's scale and our place within it. These coordinates enable us to communicate location information precisely, bridging geographical barriers. As technology continues to evolve, the role of latitude and longitude will undoubtedly expand. From autonomous vehicles to precision agriculture, these coordinates will continue to shape our interactions with the world around us. In an increasingly interconnected world, understanding latitude and longitude is no longer just the purview of sailors and geographers. These coordinates are essential for anyone seeking to navigate our planet and comprehend its complexities.